All right, so I will be working on test 17E this time around. So, let's just get started right into it. I scanned all the pages beforehand, so we could just go by pretty fast. So what negative number, you gotta make sure you look for that word, when squared equals 5 times pi. So, if it's x squared equals 5 times pi, you could just type in the square root of 5 times pi. But, again, you gotta make sure you put a negative sign out front. Negative 3.96. Kind of looks bad, but whatever. Let me try to read. Yeah, I did not like writing with a mouse cursor, but whatever. Okay, what is the average of $19.50, 19.5, plus 123, plus 54.29? And then you add them all up and you divide by 3, and that's your average. 65.60. 6560. All right. What is the remainder of 42,900 divided by the sum of e plus pi? Okay. Bang, 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 bang. So 42,900 divided by pi plus e, or e plus pi. It doesn't matter. So that's going to give you 7,320. Oh, what is the remainder? Oh, shoot. I didn't see that. So this is a remainder problem. This isn't just simply a division problem. Good thing I looked. So what is the remainder? Then you have to subtract 7,320 and then multiply it by e plus pi, or pi plus e, whatever. There we go. That'll get you the right answer. Sorry about that. I'm just going to have the answer key in the background to make sure I don't do anything wrong. So yep, that is the right answer there. So 5 point, try to redraw that. 5, my drawing is not that good. All right, 5.72 once you round to 3 sig figs. All right, the area, that's easy. The area of a rectangle is just length times width. So 3,220 times 7,920. And there we have it, 2.55 times 10. How many sig figs are there? 1, 2, 3, 4, 5, 6, 7. Okay, it's kind of hard to read whenever I'm using a computer screen. It's a little bit smaller than an actual calculator. Okay, circumference. Well, I'm sure everyone's familiar with 2 pi r, or 2r times pi. I think Braden was also, he knew this formula, of course, but not everyone really knows that you could also just use diameter times pi. I'm sure most of y'all do, but just in case you didn't know that. Since 2r obviously is the diameter, you could just do diameter times pi. It's a one-step operation. I should say that equals circumference, c. And since we're asked for c and we're given the diameter, all we have to do is plug it in like that and we get our answer, 27.8. There we go. All right. Okay, there we go. Edit, go down a little bit. Markup. All right. The population of Singapore is 5.535 million people, and 74.1% of are of Chinese descent. How many Singaporeans are of Chinese descent? That's just really easy. All right, 0.741. That's the same, just converting percentage to decimal, multiplied by 5.535 million. You can multiply that by 10 to the 6th. Thousand, million, billion, trillion. It doesn't get above trillion, I don't think, in calculator. It typically stays between that. Normally, you just see the 3 for 1,000, 6 for a million, and then 9 for a billion. Those are the ones I typically use, like 10 to the power of one of these. But occasionally do get 12 or something. But not usually. All right. So again, and what is it saying? Yeah, just give that number. 4.10 times 10 to the 1, 2, 3, 4, 5, 6. 6. Okay. If a person travels the world in 80 days, what is the average daily distance traveled? Well, this is one of those times where you need to memorize the units, right? Or at least some conversion. The radius of the Earth is is 3,960 miles. That's one thing you should have obviously memorized, right? Um, so all you have to do is multiply that by pi and by 2 to get the circumference. Remember the formula we used on the other page? That's how you, now we have the circumference. And if it's 80 days, we're going to divide that by 80. That's their total distance traveled per day. Their average, sorry, their average, because some days maybe they don't travel as much. Okay, but really the main two conversions I would know off the top of my head would be the radius of the Earth in miles, and I mean, there's a ton honestly that I could say for the second one. Uh, yeah, honestly, I would just stick with like how many seconds are in an hour, but that's obvious, 3,600, because it's just to minutes to hour. Sorry, from seconds to minutes is 60, and then you multiply by 60 again to get from minutes to hours, so it's just 3,600. That's one thing you should have memorized. Another thing is maybe just 5,280 feet in a mile, and then of course divided that by 3, and you get how many yards. So obviously the typical track is 440 yards. So I mean, if you convert it to feet, you obviously get, wait, 440 yards. I must be thinking, no. Let me fix that. Okay, so if you multiply it by 4 and then by 3, no, that's still wrong. No, no, that's right. That's right. My fault. Uh, I think I divided it by 3. I don't know why I did that. That's my fault. I think I was going to yards. That's what I was doing. Okay. But yeah, as I was saying, a 440-yard track is typical, right? So that's how many feet it is. And if you do 5,280 divided by 4, it'll get you the same answer. Not 44, just 4. So just, I would have memorized how many feet are on a track. So it's just a fourth of 5,280. And how many yards are per feet. I mean, there's a ton. Y'all know most of them, so I'm going to move on now. Okay, how many work days are in a year? A work day is any of the 5 days, Monday through Friday. Well, we're just going to assume it's, I mean, on average, so you're going to have some years that have more than them, more than the average, and some that have less. But the average is simply just going to be 5/7, right? And it's asking us how many days there are. So multiply it by how many days. And it looks like it's 261. All right, next problem. I know some of y'all probably use the triangle program once you get to here. I actually don't recommend it. If you can get faster with these, you can get them within a couple seconds without having to go into the triangle program and do like, oh, side side angle, plug in the side side and angle and get that answer. This could be even faster. Depends, right? It depends. If it's a one-step operation like that, then I would just recommend solving it by either by not by hand, but solving it using your brain, Uh, but if it's a multiple step operation, like if it asks for the area of this, then that would be 2 steps, and I would consider using the program. You just gotta be fast. Okay, this next one, we're just gonna use SOHCAHTOA, right? We have an opposite, we have an adjacent. So since we have over A, we're going to use tangent. Since we're given O and A, sorry. I kind of jumped the gun a little bit there. Tangent of the angle, 48.2, is equal to, like I said, O over A, the opposite over the adjacent. And I'm sure y'all could see where I'm going with this. To convert it, all we have to do is just multiply by that 7.76. 7.76 multiplied by the tangent of 48.2. And I'm getting 8.68, which is correct. These first couple pages should take you only like a minute each. I mean, it's very fast. You could take like 10 seconds for a problem, honestly. If I wasn't explaining it, that's probably my average. All right. The Disney Epcot Center was visited by 11.45 million people in 2014. What was the average daily attendance? And they're open every day of the year. All right, so 2014. I guess this is one of those times where you also have to know leap years, right? If, for example, this was 2014 or 2018 or something, um, yeah, 2014, 2018, 2022. I think that would be a leap year. So in this case, it's not a leap year. We're good. So I'm just going to use 365. I'm guessing that's what we have to do at least. 11.45 million. So again, that's 10 to the sixth. Have that memorized, I guess. I mean, it's really easy. And then divide that by how many days are in a year? That year, I should say, in that year. So I'm getting, this is 26. Yep, 31,400. I'm just curious, if I use the average, if I use that instead, I mean, you still would get the right answer. Because even though you're off a little bit, as long your third decimal place could be off by one digit. So you could have put either 31,400 or 300. You get credit for either one. So I'll put 300, but I would recommend actually I'll put 400 just because that's close to the answer. That's what the answer key says. So want to make sure I always round. I mean I know some others like Calvin, they'd only look at the first three digits, which you could do if you didn't make a mistake. But in some cases, like if you made a mistake in your calculations, it's best to round up or round down, depending on what that other digit is. Like if this was just a slightly higher, if let's say you got 31,500 and you put 31,300 for your answer, well then you'd be counted wrong. So I always round, but I mean it depends on how you do your calculations and how accurate you are. Of course, it won't save you. It's mostly for those smaller numbers, like the difference between 365 and 365.256. The difference between them is small, right? But it can still lead to different numbers, as you saw with that problem. Okay. What is the average of two consecutive odd numbers, integers, sorry, if their product equals 5,183? So, in this case, we just have to take the square root of it, right? Because it's their product. And whatever we get will be right in between those two numbers. So 72 roughly. So 72 is right in between 71 and 73. So we know what those two numbers are now, and we get an answer of 144. Oh, what is the average? Sorry, I didn't see that. What is the average of it? Not the. Normally it's the sum. Sometimes I've taken way too many tests. I just assume what it's asking. That's not a good thing to do. But yeah, luckily I've been catching myself though, and I'll make sure to take my time reading it from now on. I'm just a little bit distracted, with explaining the problem. Okay, but yeah, what is the average? Well, 72 then. So yep, 72, since it's right in between. All right, George runs a 7-minute mile and Jeannie runs an 8-minute mile. Or Janine, they start together running laps on a quarter-mile track. How long did it take George to lap Jean? Well, I am just going to plug that into numeric solver. So, I guess what I'll probably do is I'll convert them first before using the numeric solver. I'm going to convert it. So that is the miles per hour of George, and Jean's miles per hour is that. So they each have it's a little bit faster. I'm just gonna subtract them. So there we go. So the roughly one, I should say, yeah, George is running roughly 1.0714 miles per hour faster than Gene. We'll use that in just a second. Roughly. I'll put 3 in there just to be safe. You can round a little bit. That should be fine. Okay. And we're asking for how long it will take them to lap Gene, right? So I'm gonna convert it to feet per second, just to see how it is. Feet per second. So it's just gonna be multiplied by that and divided by that. Again, 3,600. You're going from hours to minutes, so just have that memorized. Sorry, my mic cut off there. I think there is a better fraction to use. I don't have it memorized. It's mostly for, only really recommend it for number sense, but I'm not in number sense obviously. But yeah, it's 22 over 15. I probably will memorize that actually. 22 over 15. That's a lot shorter than having to type this whole thing out. So that is their feet per second, right? So really the question is how long is it going to take them to run like the difference, right? The difference is that feet per second. So how long it will take for that difference to extend out to a quarter mile? A quarter mile, well, actually, as I was showing you on another problem, you could just do 5,280 divided by 4, and or you could just do 440, which is again yards per quarter mile lap, a regular lap, and you can just multiply it by 3. Either one gets you there, and all we have to do is just divide it. Looking at the units that were being asked in, it probably would have been smart to just convert it to feet per minute, but it's fine. We'll just divide it by 60. And we get 14.0, which is the correct answer. That's how I would have solved it. There's other ways. You could have done numeric solver and put in like each of their respective mileage, or not mileage, sorry, each of their respective speeds, and so just maybe subtracted a quarter mile from George and just see when they would have intersected, but it's whatever. You could do either or. There's a ton of ways to solve these problems. The thing with math is you gotta kind of be open to solving problems in different ways. But they do have patterns, especially when you're in a UIL event with the director that's been working there for several years. You kind of get an eye for it. All right, these two problems, just program. Geomfig. This thing is loaded up with a lot more programs than mine, so it's a little bit slower. Cylinder, and we're given the radius, and we're given the surface area. Radius is 9.42 divided by 2, and the total surface area is 963. Plug that in, height of 27.8. Some of these you could solve pretty quickly without using the program. Like if it's a rectangle, I'm trying to erase that. If it's a rectangle and it gives you two sides and it gives you the volume, I wouldn't even use the program. I would just volume divided by one side length and divided by the other, and it'll give you the third one. But in some cases, it might ask for the surface area, and it gives you. It kind of goes back to the second page where, let me show you. It kind of goes back to the second page where if like this is a one-step operation, such as these two, I wouldn't use a program. But if it is a double-step operation, then I wouldn't try to do it by myself without a program, just to save time. All right, but so for example, this thing was it was a little bit more complicated. It was still technically a one-step operation. If it gave me the surface area and asked for the volume, if it gave me the radius and the surface area and asked for the volume, I would use the program for sure. This case, I still did, and I recommend you to, just because it's a little bit more complicated, but you could have still done it. Cube, though, there's really no reason to use a program for that. I still put it in there as an option, but I mean, you all know how to do it. Cube root of the volume, and you get 13.5. Okay, but I just wanted to show you that. 36. All right, radiation dose is proportional. Oh, this is a fun one. All right. Yikes. Those of y'all that have taken chemistry that should make quick work of this. Y'all do a lot of this sort of stuff. All right. Radiation dose is proportional to the time of exposure and varies inversely with the square of distance from the source. So basically, as radiation increases, uh, I guess the radiation increases with time of exposure, and the distance from the source, the square of the distance, as if the further away you go from it, the further the radiation dose. So I'll type it in like this. I guess I'll write it out here. So I'm going to call radiation dose D for dose, right? Dose is kind of equal to the time of exposure, and it's proportional. It's directly proportional. So one way you could put that, if you wanted to have them on the same side, you could put it over T, right? That's proportional. If D increases, t must increase as well to keep the same value. But I'm going to put on a separate side, and you're going to see why. So t is over and inversely with the square of distance from the source. Again, this is another. I'm gonna put r for distance the radiation then. R, just because I didn't want to use the same variable. The radiation dose is equal to the time of exposure t. So again, it's directly proportional. And another thing you do, if you want it on the same side, you could put uh, the the distance squared on that same side. So if radius increases, for example, the distance must decrease. Although, um, again, I'm going to put it on this side as well to separate it. So we have r isolated. That's how I normally do it. And you'll see why in a second. All right, if Nolan gets a daily dose of radiation at 33 minutes when he's 30 feet from the source, at what distance does he need to get his daily dose in 5 minutes? So it gives us a pair, right, of time and of distance from the source. So we could find the R value, right? Although it would still save us some time just plugging it in directly into the numeric solver. So I'm just going to plug it in, right? I'm going to plug in R, which we know because of the first given. So time, which is 33 minutes, divided by 30 feet squared, right? That's R. That's the R value. That's the R constant. And it's being set equal to uh, the other hypothetical situation, which is he needs to get his daily dose in 5 minutes. So it gives us the time, but we don't know the distance. So we're going to use x, and we're going to square it. And the calculator, oh, I forgot. Normally, I don't recommend putting 0 in for x because if it's the denominator, it gets a little bit finicky. But it worked with us this time. And let me actually flip the page just to make sure I'm getting all the right answers. Yep, 11.7 is correct. Yeah, you got to understand what proportional and inverse look like in equations. This was just one example. You'll have to know a lot more. All right. A teenager eats 1,380 grams of food daily. Over a 2-year period, their weight increases by 23.5 pounds. What is the ratio of weight gained to food consumed? All right. So we're finding the ratio between weight gained to food consumed. I feel like that's going to be it's going to be what? Less than 1 because uh, their weight gain, like 23.5 pounds, obviously, everything you eat isn't going to increase your weight because you either I guess, sweat, you, of course, you urinate. I mean, there's a lot of things to get that stuff out of your system, right? So not everything you eat is going to add to that weight. So we're having to find that ratio between them, right? Let me quit out of this. And I'm just going to quickly convert the grams to pounds. I don't know the conversion off the top of my head. I mean, grams is in the metric system, and pounds is something that us Americans made. So, yeah, it's a little bit different. So I don't exactly know the conversion uh, off the top of my head. So using the scientific notation, the scientific calculator, or whatever, uh, I converted it and I exported it. So a teenager eats 3 pounds of food daily. That is, that's kind of crazy. All right. Um, and it says a 2-year period, so I'm just gonna multiply it by 365. I will put, I kind of messed up there. I will put 0.256 and double it. I think that's the best way to do it, but we'll see. So that's how many pounds they ate, and I mean, if I guess we're just trying to find the ratio, so all we have to do is divide 23.5 by that, and we'll get an answer of 0.0106. But it's asking for percent, so we have to multiply it by 100. And then we have it, 1.06. And we use 3 sig figs because, again, goes back to like, whenever you take chemistry, it'll actually help out a lot. You learn how to do sig figs. With dividing or multiplying, you look at the numbers that you're working with. Whichever has the least number of sig figs has the number of sig figs your answer will be in. So for example, this number has what? 4 and 6, so it has 10 significant digits, right? Whereas this one only has 3. Well, since 3 is less than 10, we're going to use this number sig figs, which ends up giving us 1.06. All right. And with adding and subtracting, I guess I'll show you that really quickly. Let's say we have like 952 and 600. If we were to subtract these two numbers, assuming that we don't have a decimal at the end there, which would mean that those two zeros are signed, they do count as sig figs. We only have one sig fig, right? Whenever we subtract them, we're going to have to go to the least specific digit in either of the numbers, right? In the ones place, we check that one first, right? This one, we have a significant digit here, but we don't have one here. So we have to go to the tens place. We have a significant digit here, but you don't have one here. We have to go to the next place. We have a sig fig here, and we have a sig fig here. So we're going to have to round to the hundreds place. So the answer, if we subtract 952 by 600 and sig figs, our answer will actually be 400, right? Another good example could be maybe like 630. So using that same logic I said before, look at the ones place. We don't have sig figs on both sides, but once you get to the 10 place, we do, right? So we're going to use the tens place as the least specific digit. So whenever we subtract these two, it's going to go to the tens place, which will mean our answer will be rounded to 320. So that's a little rundown. I know it's not much, but I'm just trying to skim through. All right. Momentum, the product of mass and velocity is conserved. Oh, this is going to be fun. I don't know if I'm going to be able to get this, but let's try it. Okay. So M is the product. I should say, I'm going to go capital M for momentum since it's capitalized right there. Momentum is equal to mass and velocity. If a 20-gram bullet were fired into a 600-gram freestanding target at 650 miles per hour, at what velocity does the bullet lodge target move? Whew, okay. So it gives us a lot to work with. It goes back to a relationship like up the one at the problem 36, but it's been a second since I've done these. All right, let's see if we can do it. So what I'm thinking is 600 grams. Well, if you're multiplying mass by velocity, mass is going to be in like pounds or I guess grams. So, and if you're multiplying them together, you're going to get grams times like feet or something. That's momentum. So we're going to have to multiply these two somehow, right? Um, and it's asking us for a velocity. That's kind of a strange. It gives us one, a 600 gram freestanding target at 650 miles per hour. Huh. This is definitely a trickier problem. It's not coming to me immediately. If I saw this on a test, I'd honestly just try skipping it and then going back to it. If a problem is going to take you more than like half a minute or to a minute, then I would just skip it and come back to it if you have more time at the end. This is one that I would definitely skip, but let's see if we can just try it. 20-gram bullet fired into a 600-gram freestanding target. At what velocity does the bullet large target move? I guess we just have to find what that m is. So it gives us the grams, right, of the bullet, and it gives us the speed of the bullet in miles per hour. And the answer is also in miles per hour too. This wasn't as hard as I thought. I think it's going to be easy. Is it 20 times 350, 650, sorry, multiplied by 60, 600, I mean, by x? Is that it? I mean, 21, we're looking at 38. The answer is 21.0. So did I do something wrong here? 600 grams by x. Okay. Momentum is conserved. Hmm. I'm just I'm just a little bit off. So what could I have done wrong? I don't think it would be by 600 and then 650. I don't think that would work, but let's just give it a try. No, that's definitely not right. It says it's conserved, so I don't know exactly what that means. I mean, I haven't taken physics yet, so this is one example of a problem that would actually help if you've taken physics. Um, so I realize my mistake now after a little bit of thinking. Um, well, whenever the bullet goes into the target, they add to the weight. So instead of the weight actually being 600, it becomes 620, if that makes sense. So whenever you account for that, which I completely forgot about, you get the right answer of 21.0. That actually is that's a very clever problem. I just completely forgot about that. So hopefully I won't get stuck on that on the regions this week. It's really just in 2 days, isn't it? Okay. Isosceles, triangle, and circle. And these two, I 100% use the triangle program. Okay. That's going to be like 2 minutes. Okay, here we go. Triangle. There's a ton of these try programs. I don't think any of them beat the triangle program though. Alright. So we have isosceles, so that makes it easy. Uh, or I guess best one would be angle side angle. 3. So I guess angle 1 is 180 minus 38.3 divided by 2. Side 3 is 0.294. The way I got that angle, I should explain it here first. First of all of the sides, the angles, sorry, of a triangle add up to 180. So these three are all 180, right? Well, we know that these two sides are congruent, right? So if I subtract 180 by 38.3, I get, I don't know, like, let's say that's 40. It's about roughly 140, right? A little bit more. I guess the exact number is 141, 140, what? 42? No, 41.7. I know number sense kids would be crashing out right now with that. Okay, so I think that's right at least. That gets you the total angled into degrees, right, of the other angles. Since they're congruent, if we divide that by 2, we get the angle of just one of them. So that's exactly what I plugged in there. Um, I'm just doing angle side angle so that I don't get two different answers. With angle side, you can get multiple answers because you're not knowing about you're not the other angle or side isn't known, right? Like for example, this angle and this side are already corresponding to each other. So this nothing about this side is given because you don't know this angle and you don't know that side. So I mean, you have this angle, so it tells you a little bit about that side over there too. You don't know that side. You don't know that angle and you don't know that side, which is why I prefer plugging in angle side angle, since this angle tells you about that angle tells you about that side, and that side, of course, tells you about that angle. So I hope that makes sense. Although you don't have to, I just think it's easy in case, um, just so I don't accidentally use the wrong one. All right, that's about big R, so just keep on going down. And there you go, 0.237. Oh shoot, I kind of drew that badly. All right, and then the next one, I guess since they're congruent and they're sharing this side, we know that this one has to also be 1.21 since it's just a mirror image of each other. And then this angle is just half of 0.86 radians. So we'll just go right back to the triangle program. We have side angle. This might actually give us two different answers. 1.21, 2.32, and 0.86 divided by 2. So now that's this little angle in radians. Now we have to convert it to degrees. Times 180 divided by pi. All right. You see? This is a perfect example. Um, it gives us a third side, which is, I mean, with what we've given it, a side and a side and an angle, that's a perfectly reasonable answer, right? But not for this diagram, right? Not for this diagram. If it looked a little bit differently, possibly, that would have been right, but that's not it. It's trying to say that this angle, side 1, that's the right angle, right? But it's saying the angle for side 2, which is this angle, it's thinking that that's 127 degrees. That is obviously not right. And it's trying to say that's 28 degrees. You see, it's a valid answer in terms of math, but for this diagram, absolutely not. Which is why the program has a built-in OR option. So now, that is a lot more reasonable, right? It's greater than this side. So 2.84. So that's why I avoided the other option. That's why I avoid doing angle side. I don't know if angle side will do that. I know for a fact that some side angles do. I don't know if all of them do, but I mean, you just have to watch out for that. Okay, now we're going on to page 5. All right, page 5. Let's crop that a little bit. Crop that up. All right. A Chihuahua dog is 7 inches tall and weighs that much. What does a 25-inch tall Great Dane dog weigh? This is pretty easy. Just set up an equation. Obviously, uh, height and weight would be relative to each other. They'd be direct, but not just height. You'd have to go volume, right? So we're gonna have to cube that. We're basically treating it like a cube, and then it's directly with weight now. So if the weight goes up, so it does the height, and vice versa. So that's why we do the division symbol. They're directly proportional. All right, and then 25 cubed over x. If you plug that in, x, again, I would recommend changing it to something other than 0, since you're dividing by it. You get x to be 114. Oh, sorry, wrong answer, blank. All right. Math. Uh, I guess we'll just use stat here. Get all those. Delete this. All right. And it tells us that a metal casting is smaller than the mold dimensions due to shrinkage on cooling. Part and mold dimensions measured on a part in inches are as follows. I'm gonna have to assume that, I mean, it's the same dimension, so I'll just assume it's linear. So I'm not gonna square or cube anything. I think that's the most reasonable. Oh no, shoot, I missed one. That's 1.91. 2.26. I think that should be right. Now 1 and 1.5 and 1.87 and 2, and then lastly 2.3. I hate having to look on my screen to type on here and then having to look back, but that's why you have to take your time. All right, and then we exit out, stat calc 8, scroll down a little bit, bang, the side dimension. So the side dimension must be 5 inches. So we're just gonna plug in 5 inches for x. Oh, I tried clicking alpha, I don't know what happened there. Alpha, trace 5. And for 47, 5.05 is the correct answer. Alright, what is tan if tan of theta divided by theta? I'm just going to use x, obviously. First, I missed it. Radian. Now we're in radian, now we can go on. Alright, tan of theta, I'm just going to use x, divided by x, is equal to 1.4. These bounds are very important, right? It tells us that theta has to be between 0 and 1. Sometimes it doesn't tell you that, and you just have to go with the smallest possible value, right? There's been a couple tests where there's actually like several correct answers. Uh, like if you have 9 out here or something, probably you see 10. Like one time during a test, it didn't have that. It didn't even say that it was looking for one under like a certain restriction of range or whatever you want to call it. Um, so I gave it an answer which was technically valid, but it wasn't the smallest possible. What I'm guessing maybe I missed was it said what is the smallest possible value, and that's probably where I went wrong. That's why you have to pay attention to this. Sometimes there is only one valid answer, but a lot of the time there's multiple, such as this one. So for this, I would just guess right in the middle, zero point 0.5 and 0.9. Yeah, I guess 0.9, 0.900 after rounding. All right. Square pyramid, we know we're given that the side length is A and the slant height is A. This is gonna be fun. This is one where the program won't work, which is tragic. All right. My instinct is just to think of to make a little right triangle. Yep, there it goes. You see, my drawing thing is pretty cool. It creates automatic straight lines for me. Um, so if we drew out this entire thing, what I hope you would see is that this. I'm gonna redraw it actually, just so it can appear nicer. All right, from this corner right there to that corner. That right there, I guess I have to go a little bit further down. That corner is exactly a square root of 2, right? You know that because this is a square pyramid, and that is 45 degrees, right? So since this side length is a, that diagonal has to be a squared of 2. But if we're only looking at the leg part, that's a squared of 2 over 2, right? Now we can scratch out one side. So it's really, this is the leg, a squared of 2 over 2. The height, of course, is what I guess we could just put that in terms of a as well. The height is going to be the square root, I'm just going to make it pretty tall, a squared, which is the hypotenuse, right, minus that other leg, minus a squared of 2 over 2 squared. You should be familiar with this formula. The hypotenuse squared minus a leg squared, uh, take the square root of that and you get the other leg, is equal to, I guess, the height. So I'm not even going to have to even set that to something. Whenever we get the formula ready, we're going to have to use this for height. All right. The formula for square pyramid's volume is going to be the side length, which is a squared times height divided by 3. Well, we know what a is. Well, we don't know what a is. That's what we're solving for. But we know what a is in terms of a. So it's just a, obviously. And height, we now put it in terms of a after using this formula from making a triangle. Um, wait. One thing I'm kind of curious about. Would that be a Would that be a 45-degree right triangle? I don't know. I guess we'll see once we get to it. I'm just curious a little bit. All right. So again, we're having to plug this in. It's for the volume. So we're gonna set that equal 9.15 is equal to. I'm just gonna use x because x is the fastest to type. X squared multiplied by the square root of x squared minus I keep on saying a, I mean x, square root of 2 divided by 2 squared. And that's the height, and we divide that by 3. Alright, and we get x equal to 3.39, which is correct. Alright, now what I'm curious about No, that wouldn't be a 45-degree right triangle. Uh, because I mean, if it was like a divided by two, no, that would be have to be square root of two. I'm still gonna plug that in because I want to know. I'm just this is full of curiosity at this point. Um, so if we did, I guess just a square root of two divided by two, x square root of two divided by two, 2.39. So that's that little bit right there. And if we do x squared minus x squared of two, I guess I'm gonna have to do parentheses, or we could just take it from here. That squared. Hmm. Yeah, it actually is a 45-degree right triangle. I did not know that. I wasn't expecting that. So this hypotenuse is the same as that base. So, that's kind of a little bit weird to think about. You have a 45-degree right triangle here, which doesn't perfectly match this 45-degree right triangle. It's not equal to each other. They're similar, of course, but they don't equal each other. But the hypotenuse of this one is the base, or the leg, sorry, of this 45-degree right triangle. And this must be, just to make it, I guess, yeah, this is a squared of 2 over 2 right here. And so is that, I guess. So yeah, if you work this out, you have square root of this is, I'm just going off of the tangent here, but I just want to see it for myself. If you distribute that, you get minus a squared, sorry, minus 2a squared over 4 is equal to the h. And if you could just simplify that to be 1/2, right? So obviously 1/2, um, sorry, 1 minus 1/2 is going to be 1/2. So 1/2 a squared. So still kind of confused where the divided by 2. So I guess you can take the a out, right? So you could just take the a out, and you're still left with a square root of 1/2. This is a long problem. Let me just look at what I was doing again. Yep, so I have this for the height. This should be a squared of 2 over 2, right? I have a by itself times the square root of 1/2, but I don't have square root of 2. I guess what you could do is if you looked at it like a fraction, right? We could still take that a out. I'm gonna still take the a out. Square root of 1/2. If you multiply each side by, if you multiply both the denominator and the numerator, would it be by 2? Yeah, it would be by 2. Yeah. We have that a square root of 1/2. If you multiply it and over 1, right? A squared of 1/2 over 1. If you multiply both the denominator and the numerator by 2, you could put that 2 into the I guess the radical uh, by multiplying the radical by 4. So you could end up with square root of 2 over 2. So yeah, it is a 45-degree right triangle. They both are. It's just that's not something I'd see on the test, and I wouldn't bank off that. That was a whole lot of writing, and it took me a second, but got there in the end. All right. Yeah, I wouldn't really mind if y'all just skip through this because this is a lot of me just having fun and figuring stuff out. All right. Oh, this one is tough. All right. Frustrum. So we know what this is, 302, and it's asking us. Okay. What I think we could do is just make a triangle, right? We can make two triangles. For the first triangle, we know what this side is. AC is 273. We know that side, but we don't know what that is. And for this one, AB, we know what that is. See this just is not fun. I guess no, since we know what that is, that we also know what that is. C to that imaginary point. Yeah, we could use that same number, 139. Since it's 139 over here, that's the slant height. The slant height over here must be 139. So yeah, we could just make a triangle. And then we could get an angle, I guess. It's kind of like a trapezoid. Yeah, it is a trapezoid. I think about it. Uh, hmm. Now what am I going to do after? I'm just going to plug it into the triangle program and see what I could work with. Alright, so I'm just going to go from left to right. 139, sure. 273. And then 302. Hmm. Well, we know that these, oh yeah, what we could do is just, we know that these angles have to be equal, so whatever angle we get over here for this triangle, right, which is, it's about to spit out, it's actually going to, once we get to angle 1, which is 27, we're going to write that down, 27.4, and it's under angle D. We'll remember that, right? It's angle D. And whatever angle we get for the last side, the 273, whatever we get for angle 2, which is 64, all we have to do is subtract them from each other. Angle E, since again, this whole thing right here, this is angle E. Since it's a trapezoid, they must have opposite angles, right? Sorry, since it's an isosceles trapezoid, aren't given, it isn't given that it's going to have the same angle on each side, but since it's isosceles, we can assume it. So we do E, angle E, which is this whole angle, minus angle D, which is that inner angle for this triangle, it gets us what this angle must be. So we know that angle has to be 37.226 roughly degrees. I kind of made a little bit more space than I needed to, but whatever. All right, so now we have angle, I guess side angle side, right? Yeah, side angle side. Triangle, side angle side, so that's option 2. It really doesn't matter what order we plug it in on. 139. Oh, I forgot the 1. Enter. Uh, oh, did I do side side angle? All right, angle side angle. Yes, 2. 139. Angle 3. All right, perfect. And then that's that 37.226. And then we have the hypotenuse, which is 273. Oh, it's not a hypotenuse. I don't know why I said that. Just that leg. And 183 rounded, which is correct. Yep, that is the right answer. What do you know? All right. So now I guess I don't even have to do that. I'm just going to move on. All right. 2 more pages. Shouldn't be too bad. Let's just zoom in down here. Zoom up a little bit. All right. What is the relative velocity of 0? Yeah, I'm not going to lie. On a regular test, I'd skip that. And even whenever I'm like running through this test, I'm still going to skip it. That is going to take me at least like 10 minutes. All right. Find the x value of the local minimum of the function. So let's get ready for that and just plug it in into this. Minus 120x squared plus 36. That's gonna be, to me, I'm just gonna guess that it's gonna be a while for that minimum, because eventually that 3x cubed is gonna win out, but that's minus 120x squared. So it's gonna be a little bit. It's not gonna take forever, but it's gonna be a little bit. So I'm gonna set the window to be like 100 should definitely work. And then actually I don't know why it's local minimum too. So we know it's going to be negative. So we could just set the y max to be like 0. Oh, okay. It's a lot it's a lot closer than I thought it was in terms of x, but yeah, the y is still way further. Probably only gets like halfway there. So y minimum, that's like, let's double that. It's not even there yet. All right. A quick note. Whenever your calculator's graphing something, if you want it to end, you could just click on and it stops. So like instead, because normally if you're graphing or whatever, and I think you'd have to press it again. If you're graphing, like you basically there's no escape. Right? There's really nothing you can do except click on, which will stop it, and you can exit the graph. A little nice trick to know. All right, calculate minimum left bound. Oh, we're already at 0, so we just have to move it down here. Where's my cursor? Oh, okay. Where is my x value set to? Yeah, it's x from 0 to 100. That should definitely work. Minimum. Where's my x at? Oh, it's all the way at the right. I don't know why it's not there, but yeah, that's definitely strange, but no matter. Bang, bang, and bang. All right, and it asks us for the x value of the local minimum. That's just going to be 26.5. Again, we're skipping 57. Solve for these matrices. And you always have to pay attention to this formula, right? I'll tell you about half the time, all it is just like S times T. Normally you just multiply the matrices, but not every time. There was one time I did that and I got the wrong answer, since I just assumed what the problem was going to be. So always make sure to read it. Even if you're trying to save time, just make sure you take a second to look at the formula. All right, 9, -4. And again, I normally type a lot faster than this. It's just kind of painful having to use my cursor to go up and down on this. Alright, just about done with the first one. And I guess I forgot to put the number out front, so I could just put it next to it. It should still be fine. Um, and we're having to subtract 2t. And I'll just do the same thing at the end there. Can I use my, oh, I can use this. Alright. This probably won't even be that much faster. Ah, you see that's a little limitator of it. I pressed the negative sign on my keyboard, but it came out as a minus. You needed a negative. If you threw in a subtraction sign there, it would throw you an error. 19 -8 6 negative. Are you sure I can't use that? That's so disappointing. All right, -5 16 and 6 and 17, and just slap on a 2 out there. And it's asking for R row 3 column 3. So this is row 3, this is column 3. So -13.0. Or I guess since it's asking for integer, you just do -13. There you have it. All right, hatched area. This is an interesting one. From 3 to 10. That's not even that interesting, honestly. I don't know why I said that, because that is an easy one. 3 to 10. I thought it was going on for infinity for a second there, but it stops at 10. If it went to infinity, then the answer would be infinite, because obviously it's increasing. It's increasing, and it's not. So from 3 to infinity would be an infinite number. Okay, from 3 to 10, it's x minus 5 divided by x, and d of x. And 39.5. Check. There we go. All right. Number 60, circle an equilateral triangle. Circle area is equal to triangle area. Sorry, I just kind of said that weird. Triangle area is equal to circle area. Well, we're going to call this whole distance x, right? X is equal to the diameter, which is 34, plus the height of the triangle. That's x. Well, and this is important to know. This is another number I kind of have memorized. When you're dealing with equilateral triangle and you split it in half like this, it makes another 30, 69. It makes a 30, 69, 90 triangle. And which means this little side right here is going to be x. Well, I guess since we're using x, it's just x divided by 2. And this, which is the hypotenuse, which is the side of the equilateral triangle, is just, wait, no, I meant, sorry, x divided by square root of 3. That was what was wrong with my formula. And then that's going to be 2x divided by 3. Square root of 3, sorry. There we go. All right. So let's just go down here. I guess we could use uh, x minus 34. No. I'm just going to keep x as the height of the equilateral triangle. That's what I'm going to do. And then at the very end, I'll add 34. All right, so half of 34 is obviously 17. 17 squared times pi. That's the area of the circle. And since it's equal to the triangle area, another number you have to have memorized is the how to go from the side of an equilateral triangle to the area. It's going to be the side length, which is again that 2x divided by square root of 3. That's the side. Squared times the square root of 3 over 4. There was one time I actually worked it out and figured out why it was that. It's pretty quick. All right, this is number 60. So we get x equals to 39 points whatever. So x plus 34, and we get 73.7. Shoot, I kind of wrote that 7 weird. Which is the correct answer. All right, moving on. Let's see what we can do on this page. What is the percent error for assuming 3.1 for pi? Luckily, Calvin has a cool program. It's not even on this calculator, actually, now that I think about it. But Calvin did make a new program. I say new. It's been a few months, probably. Uh, this is the old one. It would just give you the formula. So Calvin's is a lot faster than this one. Percent error. So you look at error, b is the exact. So 3.1 divided by the exact, which is, we're just going to use pi, minus 1. And for 61, I got negative 1.32. Or negative, yep, negative 1.32. You might have had to round up there for a second, but no, the 9 was on the fourth. Fifth, sorry. Okay. There are 256 professional football games in a season. What is the probability of correctly wild guessing the winner of every game for 10 seasons? This is an exponent problem. All right. So to guess the winner of each game of this, that's a little bit more work than you typically do for the exponent problem. Let's see what we can do here. All right. So to guess correctly, the winner for 1 is just 1/2 squared, right? It's just, sorry, it's not 1/2 squared. It's just 1/2. And there's going to be how many rounds? So I guess there's 255 games, right? There's going to be 255 total matches. So I guess it's going to be 0.5 to the power of 255. That's going to be numbers like almost, it's super small, but it still counts, right? And then you're going to have to put that into the exponent problem. All right, or program. I think that's it, at least, from what I can tell. All right, let me be right back. All right, I'm back. Uh, so yeah, this is just what I'm guessing, right? The base is 1/2 to the power of 255 because that's how many matches you have to play to win. But not, sorry, that's not how many matches a team has to play. That's just how many games there are. Never mind. There's 256 matches. Sorry. Um, I was thinking that there were 255, like 256 teams, which mean that you would have to play 255 matches. But no, that it just gives us the total number of games. There was another time on another test where it gave us the number of teams, and you have to figure out the number of matches or whatever. So a little bit different. So yeah, let me fix that. So 1/2 to the power of 256 and the probability of getting it for every 10 years, or all in a row for 10 years. I think that should be it. Yep, 2.31 times 10 to the power of negative 771. That's a very small number. With all these problems, they're very, very small numbers, or they're very, very large numbers. That's why we call it the exponent problem. All right. I remember freshman year, I was kind of being taught how to solve these normally without having to use a calculator. And I actually made a mistake there. I wrote a 0, but that'll still give me the right answer. They'll still count it because it's within one digit. It's within one digit of the actual answer. Okay. A motorcycle stunt driver plans to bike up a ramp inclined at 25 degrees and to jump a bunch of cars, landing 120 feet away. What is the minimum velocity? Okay. I know I've been talking a lot about numbers you need to memorize. For trajectory, 45 degrees is it's the perfect number. If you only know one angle for the trajectory program, it would be 45 degrees, right? That is the perfect arch, basically. That's the perfect angle for something to be thrown at. In terms of speed, in terms of distance, all of that, basically. I mean, the one thing I guess would be if you're dealing with something that's like max height, in which you just throw it up right into the sky. Like just how high up could you throw it? You just throw it right up into the sky, but still, um, that's normally not the case. For these for these problems, like especially this one actually, trajecto, where is it? Right, I skipped it. 45 degrees, right? So 45 degrees. That's what we're gonna use actually. Uh, all right, no, I said that. I was saying that, but actually it already gives us the angle, and it gives us the total distance away. So let's see. The real question is, how high is the ramp? Cause oh no, it doesn't matter, does it? Yeah, the ramp doesn't matter because it's going to it's going from that ramp from zero. We're gonna treat it as zero. Yeah, that's the initial height because it lifts off from this ramp. And it's yeah. I went on a little spiel about 45. Normally, in this case, um, in this case, some cases like this, I mean, it doesn't give you an angle and you just have to use 45. But it does this time. Okay, but what it tells us, the other third thing we know though, is the initial height. We're gonna treat the different ramps as the starting ground, right? We're gonna treat it as like the just overall where it starts and hits because obviously he's gonna lift off from this ramp and he's traveling 120 feet away and he's gonna hit the second ramp, which is we're going to assume the same height up, right? So we're just going to have to use that initial height. I'm gonna first do horizontal distance, and we know the angle. Angle is 25 degrees. The horizontal distance is 120, and initial height is, I guess, yeah, 0. And minimum velocity, again, this is another one that I don't really like. Minimum velocity is kind of weird, but we're just going to, I mean, we're going to assume that this is the best. Oh yeah, that's already in feet per second, so we have to divide it by 5,280 and multiply it by 3,600 to get the right answer. You could have also just multiplied by 15 and divided by 22. I remember that conversion now. Okay, this did get us our right answer. Yeah, sometimes when it gives something like minimum or maximum, sometimes the program doesn't work. In this case, it does, which makes sense because technically he could have gone faster and still made the jump. So that's just his minimum velocity. That's the program's treating it like he lands right on 120 feet. But he could have made it further, faster, whatever, you know. So that is it. Two more problems and then we're done. Um, Congruent squares and semicircles. We're asked for the distance between these two. Okay. Let's just think about this. I'm going to make a triangle. I feel like that's just the best way to start off. An isosceles triangle here. There we go. Thank you for fixing my mistake. Now the question is, can we assume these two to be equilateral triangles? I don't know. I don't think so. Well, I mean, actually, no, we can't. Because this is R, but we know what we can. I know we can do this now though. This is R, right? And since this is also R, did actually no, it is an isosceles triangle. I don't know what I'm on about. Yes, it is an it's an equilateral. Obviously, it's isosceles. It's also equilateral, right? So this distance should be splitting in this in half, right? Sorry, I'm not describing it that well. What I'm doing. Okay, let me try to restep. So we made a triangle. I just wanted to make sure it was first of all isosceles, which it is because obviously that's a radius and that's a radius, and this is also a radius. So since these three sides are all radii, we can know, not just assume, we can know that's is an equilateral triangle, right? So knowing that, if we split it in half, right, and make another right triangle here, we know that this angle is going to still be 60 degrees. and this angle is going to be half of what it was, 30 degrees. So it's a 30, 60, 90, right? So, and y'all know what to work with, how to work with these now. So we have r divided by 2 right here, and this is going to be, okay, sorry about that, my mom came in. All right, so going back to this problem again, we have r divided by r divided by 2, and this is going to be r times the square root of 3 over 2. Sorry for my bad penmanship. Okay, and we could just double that to get this side as well, right? So I think the answer should just be 2.1, since that's the whole diameter, right? 2.1 is the diameter. If we divide that by 2, that'll get us the radius, and all we have to do is just multiply that by the square root of 3. These problems look very daunting at first, but they're honestly not too bad. You just have to have an eye for them. That's what I always say. All right, 1.82. Okay, circle with tangent lines. Total area. So I'm guessing it's the total area of the figure, but that's it's gonna be fun. All right. So let me draw this out. Okay, so now that's 90 degrees. Yeah, that's actually not that bad. All right. So as you can tell, I mean, as you've seen throughout this entire video, um, I always make triangles. Triangles are super friendly, right? Especially 30, 60, 90 triangles, 45 degree right triangles, or just overall right triangles in general, right? Those are always my favorites, right? I mean, I've gotten to know them very well over in like 2 years I've had a calculator now, almost three. Um, they're very useful. Try to make a triangle whenever you can, right? That's my recommendation. Um, and again, there's several ways to solve these problems. There's several ways to solve these problems, but using different methods, some methods are just overall better than others, right? And triangles are typically like the best, right? They're the fastest and they're the easiest. So for this, I'm just going to make a right triangle. Since it's tangent, we know that this intersection, I should say, we know it's tangent, it's given to us. We know that that intersection must create a right triangle, right angle, which if we create an imaginary line, will give us a right triangle. Okay, and um, we know that the radius is 0.466, 0.466, and we can figure out what this angle is by doing 90 minus 20, which is, since again this is 20 and this is 90, all we have to do is 90 minus 20 and we get 70. So that angle is 70 degrees. So I'm breaking this thing into I'm breaking this whole shape, this like the circle with the lines, into two separate parts, right? I'm gonna break it into these two parts, right? I'm gonna find the area of these, and I'm gonna find the area of this outer circle part. So for this shape, since it's congruent, right? Since it's a mirror image, all we have to do is find the area of one of these, and then double it. And then once we double it, it'll include the area of that as well. So we could do that really quickly. Let's just use tangent, right? Tangent, it's over A. So if we multiply each side by A, I'm just going to use this then. So tangent of 70 multiplied, not inverse tangent, just regular tangent of 70 degrees multiplied by 0.466 will get us this side length, right? And if we multiply that by the 0.466, that'll get us the area. We could just leave it like that because uh, you could make a you could divide it by 2 and then get the area of this triangle and then you'll multiply by 2, but it's the same operation, so they cancel out. So I'm just going to leave it like that. This is the area of this shape right here, right? Just to make sure, just to clarify, what we did was found this angle, right? And since we used SOHCAHTOA, tangent of the angle is equal to over A. What I did was multiply side by A, which is 0.466, by the tan of 70 to get the opposite, right? And I have it right there. That's the opposite angle, right? Not the opposite angle, the opposite side. And whenever you multiply both legs of a triangle together and divide by 2, you get the area of the triangle. But we actually have a rectangle in a sense. If you were to move this around a little bit, you could make a rectangle if you kind of flip it. Or yeah, it's kind of hard to show. But if you kind of flip it, then you'll have a rectangle, which is why all I'm doing is just multiplying them and leaving it like that. Okay. So, since we know this angle is 70, if we multiply it by 2, we'll get the entire angle, right? So 140. If we do 360 minus 140, we'll get this angle right here. So we know this angle is 220. Um, a lot of y'all are already familiar. Whenever you have an angle of a circle, right, like I don't know, in this specific case, 220, if you divide that by 360, that'll tell you the ratio of the circle that is in that angle part. So 61% roughly of this entire circle is made up by this section right here, right? That makes sense. And with that knowledge, if we use the regular equation for the area of a circle, which is 0.466 squared, the radius, multiplied by pi, and we multiply it by that fraction, it'll get us this area. And if we add that area to the area of the, I guess, rectangle we found, or the two triangles, whichever you want to call it, if we add them together, we get 1.01, which is the correct answer. Well, I think that'll do it. Sorry it went a little bit long. I mean, it typically does go a little bit longer than an hour, especially with all my yapping, but we did some pretty good work. So, only one we skipped was 57, if I remember correctly. So, I'll try to post another one when it comes around time for state. And, of course, summertime, because next year will be our year. I can guarantee that. Y'all have a good night.